So today's lesson, we're going to be working with compound interest. What is interest? Interest essentially is payment from a borrower. It is an amount, usually an amount above repayment of the principal sum at a specified rate. So that basically means if you're going to go to the bank and you're going to ask them for a loan, they're not just going to basically give you this money for free. They're going to want something in return. So they're usually going to charge you an interest rate. So basically, you take out $1,000 loan, whatever that interest rate is. The bank makes that interest money. That's essentially like their payment for you for letting them give you the money to borrow. There's two types of interest: simple and compound interest. The first one we're going to work with is simple interest. Simple interest paid over a certain period is a fixed percentage of the principal amount that was borrowed. And the one we're going to focus on the most right now is compound interest. Compound interest accrues. So accrues means it builds up over time and is added to the accumulated interest of previous periods. So borrowers must pay interest on interest as well as the principal. So that basically means if you guys are in the first time car buyers, you're looking to purchase a car, well, you're going to need a car loan. When you take out a car loan, each month interest builds up. So say your car costs, now I'm just making this up, like $20,000, and at the end of however many year loan or whatever, you end up paying, just say for easy purposes, $25,000. That extra $5,000 is the interest. You paid out an extra $5,000 because you needed to borrow money from the bank. So that interest is building up over time. And it accrues. That's important to remember. It builds up. So compound interest, think of it as interest on top of interest. So we have compound interest. The formula for compound interest is as follows. A, and then in parentheses T, AT is equal to P, and then in parentheses 1 plus R over N, close our parentheses, raised to the N times T power. A is equal to our final amount at any given time. P is equal to the principal, which is the initial amount. R is equal to a rate as a decimal. N, it's in two places in this formula, is the number of compounds per year. And T is equal to our time in years. Now, what's important to remember here is rate is always as a decimal. You cannot say 9% with the little percent symbol. It has to be converted to a decimal. We're going to go over how to convert percentages to decimal in just a minute. And our time is always in years. And if it's not in years, if it's in, say, days or weeks, we got to go ahead and convert that into years. So when we're putting into our calculator, we have to pay attention to the parentheses. So the first thing I always like to do is I like to multiply this N times T, put that in parentheses. So simplify this first. Multiply whatever N and whatever T is together first. So then you're going to be left with AT is equal to, and then in parentheses, 1 plus R over N, close your parentheses, to the NT power. Then what you have to do is you have to put R over N inside parentheses. So when I go ahead and plug it into my calculator, the first thing that I'm going to do is, you see how I highlighted this box over here in pink? What I do is I open I don't even open a parenthesis at this point yet. What I do is 1 plus, and now I go ahead and open my parenthesis, R, whatever our R is, divided by whatever our N is, close parenthesis, and then hit enter. Then we get a number, and then what I like to do next is put the little power symbol, or the caret button on our calculator, and then whatever I got when I multiplied N times T together. Most of the time Now, once you raise it to that exponent, you're always going to get like some form of a decimal. So then once we get that, you multiply that decimal by whatever our principal amount was. So make sure when we put it in our calculators, we put with all those parentheses. You could put it all in at once, or what I like to do is I like to do what's in this. I multiply the n times t power out first, get a number. Then I put what's in this box in the calculator first, raise that to the n times t power, and then multiply it by whatever the principal was. So how do I convert a percentage to a decimal? There's two ways to do it. Way number one is you would do the percentage over 100. That way you can go ahead and do it that way. Way two is the way I personally do it. I think it's a little bit easier and it's a little more straightforward for some of you guys to see it. So what you're going to do is you're always going to move the decimal point 2 places to the left. Essentially, way one and way two are exactly the same thing. It's just a little more straightforward to move the decimal point 2 places to the left. So let's convert the following to decimals. 36%. Remember, there's like a little imaginary decimal point right after the 6. So we go ahead and move it 2 places to the left, and we're left with 0.36. 125%. It's okay, it's over 100%, that's fine. Remember, the decimal point's always going to be after that last number. Move it to the left 2 places, 1, 2, and 125% to a decimal is 1.25. 6%. Okay, so remember, decimal point is right after the 6, so we move it over 1. Okay, but now there's really, where am I supposed to move to next? That's okay, remember, move it over one more time, put the decimal point, and then just fill in a 0. So basically, anything from 9% and below is going to be 0.0 and then whatever the number is. Anything 10 and above, it's going to be 0.1 and above. 0.2%. Okay, this is definitely under 1%, but you could still go ahead and do that. All you would do is still move that decimal point 2 to the left. So we move it 1, and then remember one more time, that makes it 2. Fill in that extra 0. So 0.2% becomes 0.002. Time, as I told you in that formula, is always going to be in years. And then here's just some terminology that will help you how you guys are going to see it in the problem. So this might be helpful for you guys to write down. So monthly is always going to be 12 because there's 12 months in a year. Weekly is going to be 52 because there's 52 weeks in 1 year. And daily is always going to be equal to 365. Annually is equal to 1. Semi or biannually is equal to 2. Quarterly is equal to 4. And not so commonly, you guys might see it every once in a while, triannually, and that means 3. So let's dive right into the first problem. $1,000 is invested at 1%. It's compounded semi-annually for 10 years. What is the amount at the end of 10 years? What is the interest earned? So this problem, I'm asking you, what is the final amount? So what is AT at the end of 10 years? And then I'm also asking you, what is the interest earned? So it's kind of a 2-part problem. As always, when we talk about, when you see compounding, we're going to use this formula for compound interest. And we know our P, our principal, that's the initial amount we have, is 1,000. Our rate is 1%. So our rate as a decimal is 0.01. Our number of compounds is 2 because it's compounded semi-annually. Our time is 10 because it's compounded semi-annually for 10 years. So now we could go ahead and plug everything in for the letters. So we're going to sub in 1,000 for P, 0.01 for R, 2 in for N in both spots, and 10 in for years. We can now go ahead. First thing I would do is multiply this 2 times 10 and we get 20. And then what I do at this point now is I do 1 plus, open my parenthesis, 0.01 divided by 2, close parenthesis. I'll hit enter, get my answer there, and now put that little caret symbol, and then I'm going to put in 20. I'm going to hit enter now, and then from that answer, I'm going to multiply that by 1,000. So our final answer is $1,485.95. That is how much money we will have at the end of 10 years. Now for interest earned. How much interest did I get on this investment? What I got to do is I got to take this $1,485.95 and subtract it from the initial amount. So subtract it from 1,000. So 1485.95 minus 1,000 gives me $485.95. So basically, I invested my money, I put it in the bank. I let it sit there for 10 years. It was 1% interest, compounded semi-annually for 10 years. So at the end of 10 years, just for leaving my money in the bank, I make $485.95. Practical applications. Your new car cost $28,000. Interest is 5% and it's compounded monthly. Anytime you're going to be paying a bill, like most of the time, car payments, a credit card payment, but if you don't pay the credit card off in full every month, you're going to be charged interest, and that's going to build up over time. Car payments, prime example of interest that's going to be compounded monthly. Car loans are usually at least 5 or 6 years, so you're going to have a 6-year loan. What is the total cost of the car after 6 years? And then I want to know, what are your monthly payments? So we're going to go ahead and plug into this formula. We know our principal is $28,000, so we're asking the bank to borrow $28,000. Our R is 5%, and remember 5% has to be converted to a decimal, so it's 0.05. Our number of compounds is 12 because it's monthly, and our time is 6 years because we have a 6-year loan. So we go ahead and plug that all in. And at the end, once we plug this all into our calculator, we get $37,772.50. So basically what this is meaning, your sticker price on your car is $28,000. At the end of 6 years, you've paid a little under $38,000 for your $28,000 car. So pretty much the banks we're going to go ahead and figure this out, but the bank is making that extra money. So now we want to figure out, okay, well, we have our loan at the end of 6 years is now $37,772.50. What is my monthly payment? Well, to figure out your monthly payment, we're going to take 6 years and multiply that by 12. 6 times 12 gives us 72. So we take the ending amount, divide that by 72, and roughly each month you will be owing $524.62. So basically, like I told you, as the initial amount that you're asking for, the initial amount of your car is $28,000. You're needing to borrow that money from the bank. They're not going to give you that money for free. They're going to want to make something off of it. What they're making is that difference between the initial amount that you asked for and that ending amount over here. So if we rounded this to 38,000 for easiness right now, your bank would be making $10,000 on your loan. So now what would happen if you left a $5,000 down payment? So now your initial amount that you're asking for is $23,000, and it's going to be at 3.5% monthly for 5 years. So, principal is $23,000. We're going to convert our 3.5% to a decimal, and it's still 12 compounds, and it's going to be now for 5 years instead of our loan. So now at the end, our new total for the total cost of the car is, or the total cost of our loan is $27,391.69. That's not bad. So, but remember, you only took out $23,000 at this point. We had already taken $5,000 off that initial amount of that loan. So what you would do is the total cost you're going to end up paying for your car, you're going to take this number right here and add $5,000 back to it. So your overall cost for your car is now $32,391.69. And if we wanted to figure out how much our monthly payments would be, we would do $27,391.69, divide that by 60 payments, and then our monthly payment would be $456.53. Okay, so now we're going to work with the same problem. You put $5,000 down, but you kind of really don't want to be stuck with a car payment for 5 or 6 years. You want to pay it off sooner. You want to do it in 3 years. So the bank says, great, now your interest rate is only 2.8%. So we go ahead, plug in our principal. So principal is still $23,000. 2.8%, got to convert that to a decimal. So then we put 0.028. N is still 12, and our time is now 3 years. We go ahead and do that, and our final amount of the loan after 3 years is $25,013.02. So with $5,000 down, your total cost will now be $30,013.02. And because we're talking 3 years, we'd have 36 monthly payments of $694.81. So basically what ended up happening is shorter loan time, your payments went up a lot more monthly, but what ends up happening is your total loan amount becomes less because you're paying the bank back quicker for their money. But what if you have excellent credit rating? So if you have like a perfect credit score, you'd have 0% interest over the next 5 years. So you'd pay $28,000 exactly, which is great. Your monthly payments, so all you would do is $28,000 divided by 60 payments. So your monthly payments would be $466.67, which isn't too bad. So basically, most of the time, you're not going to get that 0% interest. Most people are paying this 2.8% or whatever. Most people who, it's kind of expensive to have almost $700 every month just for a car payment. So that's why a lot of people will go ahead and spread it out over 5 or 6 years, because then your monthly payments go down a bit. So for today's pets of the day, this is Matt's dog, Wrigley. So as we could tell, Wrigley's adorable. And in this picture, he's eating some doggy ice cream. A fun fact about Wrigley is he doesn't like walks, but he loves treats. And this is Kitty. This is Bella's cat. Kitty was rescued from the streets of Patterson. Kitty is feisty and she knows she's a cutie. So some daily reminders. Your homework is assigned daily and it's posted on Plus Portals. Your homework is to be emailed to me before the start of class. If I don't receive it prior, it's considered late. So if you're emailing it to me in the middle of our class time, it's late. And you will not receive full credit. When I receive your homework, I will send you an email email back acknowledging that I received your homework. And if you guys have any questions, please make sure we're emailing me them and I'll get back to you as soon as I can.